Okay, so this is lesson 1.2 out of the Rates, Ratios, and Statistics book. In Mrs. Walker's class, we are on page 100, and lesson 1.2 is titled Geometric Sequences. Geometric sequences. All right, so warm up on this lesson. Warm up. 1. Simplify the ratio 10:8 and write 3 ways. If you're not sure what write 3 ways means, look back in lesson 1.1. All right, number 2. The Seahawks had a win to loss ratio of 1:1. Explain what that means. And for those of you who know that I am a fan of the Seahawks, I find it necessary to let you know that they stink is not an appropriate answer. Although that does seem to be what this ratio implies. I think the original problem said the Eagles, but I changed it to the Seahawks. I'm not sure why. I just made them look bad. Oh well. Okay, so number 3 in your warm-up. Number 3. Kurt had 6 yellow flowers and 8 pink ones. Write the ratio of yellow to total flowers. All right. Okay, and then our I can statement for this lesson is I can recognize and complete geometric sequences. All right. All right, here we go. For this lesson, I have one note slip, put it in the usual upper left, and then we'll talk about the vocab for this lesson. This is a pretty short lesson, pretty quick. Oops, I want to put it upside down. Okay, so vocabulary. I need my yellow highlighter. And the vocabulary we will be discussing is sequence. Sequence is an ordered list of numbers. Okay, we've seen this before. Right? A term is a number in a sequence. So each number in a sequence of number is called a term. So in this sequence here of 1, 2, 4, 8, and 16, then this is your first term, second, third, fourth, and fifth. Okay? All right, and then the definition of a geometric sequence is a list of numbers created by multiplying the previous term in the sequence by a common ratio. So we got to figure out ratios and then multiply. So I'm going to underline multiplying and ratio. That's what's happening when we're dealing with geometric sequences. Now, when we were in the last block of our Intro to Algebra book, we talked about recursive sequences. And recursive sequences always dealt with either increasing or decreasing numbers by a common number. So either they were all going up by 2 or down by 3, something like that. And in geometric sequences, not addition or subtraction, it's multiplication. And that's our big difference here. So on the good to know, it says the number you multiply by each time to get the next term is the ratio between the terms. The ratio can also be determined by writing the ratio of each term to its previous term. And that's basically what we'll be doing here. That might sound a little bit confusing, but when you see it in action, this one really isn't very hard. I think you guys will get this pretty quickly. All right, so real short notes here. Here's what we're going to start with. Find the ratio of each geometric sequence. Use the ratio to find the next two terms. Okay? All right, so part A. Here are our numbers. 1, 4, 16, 64, and then we're going to find out what this number is and what this number is. ... The sequence will go on and on. All right? Okay, so how do we do that? Well, with my yellow or red pencil, I am going to write to find the ratio. Remember, we have to find the ratio before we know what it is we're dividing by. Multiplying by. To find the ratio, divide one term, and you can pick any one term by its previous term. I'm going to take my blue highlighter and highlight this. This is very important that you can find how to do this. If you can't quickly figure out how to find the ratio, you won't know what it is you have to multiply, in this instance, 64 by to get the next term. So again, I always try to use my smallest numbers. So I could choose this term right here, 4, okay, divided by the term, its previous term. What's its previous term? 1, right? And 4 divided by 1 equals 4. So 4 is the number that I will be multiplying by. So to get my next, my ratio is 4, and my 4 to 1, and what I'll be multiplying by is 4 to get the next term. Well, 64 times 4 is 256. 256 times 4 is 1024. Okay, that's my next two terms. And that's how we do it, right? I'll show you one more example here. Make sure that you have it, but it really is that simple. All right, so part B. Now we have 81, 27, 9, 3, next term, dot, dot, dot. All right? Okay, so now you notice the numbers are getting smaller instead of larger as they were up here. Okay, but the process is still the same. Finding the ratio is still the same. So my ratio, I have to find it first. My ratio is, and I'm going to choose, let's see, 3 divided by 9. That looks nice and simple. 3 divided by 9. Correct? And that simplifies to, well, 3 goes into itself once and 3 goes into 9 3 times. So my ratio is 1/3. All right? So now I have to find the next two terms. Next terms. How do I find that? I'm going to multiply 3 times my ratio, 1/3. All right? So nice and simple here. I've got 3, which I'm just going to put over 1. That's my last term that I know of. Times 1/3 equals 3 over 3, which equals 1. So my next term in this geometric sequence is 1. Okay. Now the next one I need to find, again, now I'm going to multiply 1 times 1/3, still by my ratio. So now I have 1 over 1 times 1/3, which equals 1 times 1 is 1, 1 times 3 is 3. And so my next term in this sequence is 1/3. And if I wanted to know what the next number was in the sequence, I would multiply 1/3 times 1/3, because that's my ratio. All right? So that's how it goes. Really, it is that simple. Let's take a look at some practice problems and see how we're doing here. Okay, so practice problems for lesson 1.2. The first one has 3 different geometric sequences. You've got to find the ratio in order to find the next 2 terms. All right, so here's the instructions. And then here's the 3 sequences. Find the next 2 terms. And the second problem is write the first 5 terms of a geometric sequence. They're giving you the first term and what the ratio is. So you're going to write the first 5 terms of the geometric sequence, starting with the first term they give you. All right? Okay, let's see how these work out. So, on the first ones here, we have, where'd my pencil go? Oh. Okay, so on the first one here, we have to first figure out what is our ratio. Okay, so remember, we take any term and divide it by its previous term. So I'm going to take 5 divided by 1, which equals 5. That's my ratio. So whatever I do, I can see that 1 times 5 is 5. 5 times 5 is 25, and so on and so on. So 125 times 5 is 625. So that's my next term. And 625 times 5 is 3,125. All right? That's how we do it. Okay, let's look at B. B, the numbers are getting smaller, but the process is still the same. So I'm going to take 400 here, divided by its previous term, 800. All right? Well, how do I do that? We simplify. Okay? So I can simplify that all the way down to 1/2, because I can see 4 goes into itself once and 4 goes into 8 2 times. So that simplifies down to 1/2. That's my ratio. So to get my next 2 terms, I have to multiply 100 times 1/2. Now remember, whenever you're multiplying anything by 1/2, it's the same thing as saying 1/2 of. So I don't even have to do any math here. I know what 1/2 of 100 is. It's 50. And I know what 1/2 of 50 is. It's 25. So those are my next two numbers in the geometric sequence. All right, so B. I find students start seeing these fractions here and start thinking, but remember, the process is still the same. First, we find the ratio. The ratio is one term. I'm going to pick 1. Divided by its previous term, 3. All right? So that is the ratio. I can't simplify that anymore. Right? So to get my next one, I have to multiply 1/9 times 1/3, right? And remember, multiplying fractions is easy because I can just say, we're just multiplying across the numerators, multiplying across the denominators. So 1 times 1 is 1, and 9 times 3 is 27. So my next term is 1/27. So times 1/3 again, right? 1 times 1 is 1. And 3 times 27 is 81. So there's my next term. Done. Sorry, it's got a stuffy nose, guys. All right, so number 2 on our practice problems. Write the first 5 terms of a geometric sequence. All right, they're giving you the first one and the ratio. All right, so I know my first term is going to be 1. And I know I'm multiplying by 3 every time. So 1 times 3, of course, is 3. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. Okay? Is that 1, 2, 3, 4, 5? Yes. So there's the first 5 terms of my sequence. Actually, if I was writing this correctly, I'd put a comma here and dot, 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 because it's the very definition of a sequence is that it will go on and on and on and on as many times, infinity, as every time I multiply the last term by 3. All right, so on this one, our first term is 10,000, and we're going to be, I'm going to put a semicolon there. We're going to be multiplying by 1/10. Well, when you multiply 10,000 by 1/10, you're if I put this over 1 and then I multiplied 10,000 by 1 and had it over 10, well then 10 goes into 10,000 1,000 times. So we're down to, we just keep dropping off a 0 when we're dealing with these. Now when we do it by 1/10 again, we get 100. And now when I do it again, I get 10. And now when I do it again, I get 1. So if you understand how numbers with zeros work, the magics of 10, then you don't have to do a lot of math. But you could have long-handed that all out by multiplying every number, putting it over 1 and multiplying it by 1/10 and reducing. Sure easier if you understand how those numbers work, though. All right, so those are your practice problems for lesson 1.2. Let's take a look at your worksheet. Your worksheet is... the first part of it is talking about find the ratio of each geometric sequence and use the ratio to find the 2 terms. So the next 2 terms. So this is the same as what we did at the top of the practice problems and in your notes. First, you have to pick a number and divide it by, pick a term and divide it by its previous term to find out what your ratio is. And then multiply the last number in your sequence by that ratio to find out what the next term is. Okay? Make sure you write down your ratio and the next 2 terms right there. So that's all of this. Now, this one is what we did at the bottom of our practice notes, our practice problems. They're giving you the first term and the ratio. Oops, am I off here? They're giving you the first term and the ratio. So you'll write down the first term and you'll keep multiplying by whatever the ratio is until you have 5 terms. All right, now on this one we didn't cover in our notes, so let's talk about it for a second. It's determine whether or not the sequence given is a geometric sequence. If the sequence is a geometric sequence, then write its ratio. Look, if you can't multiply this, well, from 1 to 5, it'd have to be times 5. So is 5 times 5 10? No. So I'm just going to tell you right now, that is not a geometric sequence. You have to be able to figure out what a ratio is and see if it works as you multiply it on down the line. If it does, then tell what the ratio is. And 16 and 17, I think you guys can figure those out. Write the first 5 terms of a sequence when the first term is 1. and whose third term is larger than 20. So remember, you're multiplying. What would you have to multiply 1 by to get the third term to be bigger than 20? Okay? All right, so that's your worksheet. That leads us to our exit ticket. Oops, get that set out a little better. Exit ticket for lesson 1.2. As always, I don't give you the answers to these, and I don't show you how to do them. They're for extra practice. Okay, so that's lesson 1.2 out of the Rates, Ratios, and Statistics book. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.